This Harrison 140 lathe is metric. I need to cut an imperial thread. So to cut the imperial thread, we need to change the gears in the headstock of the lathe. That's the main shaft throw. There's a couple of tumbler gears. The top one, that's an idler, and that drives the gearbox. At the minute, it's set up for metric. It's straightforward gear train. And what we have to do is put a compound gear train on to convert it to imperial. There's two gears going here that give a ratio that give us imperial thread. So I've got a chart that shows how to set the gearbox up to get whatever thread we need. It's nice and oily in here, that's the way it's supposed to be. All these gears are held on by keys. You can make sure that the keyway on this one's at the top because it has a nasty habit of falling out. We don't want that to be happening. Right, so I'll select the right gears off the chart and then we'll put it back together. Right, the top gears are 50, that goes onto there. The 50 then drives a 63, which is this one. That's actually a gear I made. And then we need a 40 on there, which is that one. Another gear that I made. It's a fibre gear. It just happened that I had the fibre. And the idea is if something goes wrong, it'll strip the gear instead of damaging the lathe. And on the bottom here, we'll have a 120, which is driven off that one. So that one drives that one, they're connected together, then that one drives a 120, and that should give us the correct ratio. This thing here is called a banjo for obvious reasons. Looks like a banjo, I suppose. The spacer goes on there. Then the 120 gear goes onto there. So that drives that one. You need clearance between these gears. It's nice having them tight or they'll bind up. A little bit of backlash, that feels good. We'll bring that up to mesh into the top gear. Come on, John. Like that. They're noisy, they always have been noisy. It's just the way they are. There is clearance in there. They're just running nice and slow anyway, so it won't do any real harm. I've been going to make a spacer for that as long as I've had the lathe and I still haven't done it. You hear them rattling about, which is what you need. A little bit of lube won't do any harm. That's an important nipple, that one on the end of there. That's what lubricates the bush inside of there. That's it. See, a real filthy operation it is. This is the chart that shows me what I need to do to cut the thread. We've just done the gears, so we'll put a 50, driving a 63, driving a 40, driving a 120. That bit's done. We'll move on to the actual gearbox itself now. Right, we're looking for 12 TPI, which is that one there. So I put the tumbler into that position, which is the third, fourth one along. Those two levers go to the left, and this one here, which is the extra lever that only the certain Harrisons have got, that goes to the right, and that will give me 12 TPI. Right, this is a quick change gearbox. So for 12 TPI, we need to bring the fourth one along. 1, 2, 3, fourth hole, that one there. Then these two levers need to be to the left, and this lever needs to be the right. It's as simple as that. That is now set up to cut 12 TPI. I'll check it again. 1, 2, 3, 4. Both to the left, the magic lever to the right. We'll set the tool up, do a real fine scratch cut, just to make sure we're cutting the 12 TPI. That's a 12 TPI cutting insert. We need to make sure it's nice and square to the job. I know it's on center 8 because I use this tool quite a lot. We'll check it just to make sure. So we need to make sure it's touching all the way along, and that means that that tool is indexed exactly at 90 degrees to the job. There's two shafts on this lathe. The bottom one is the one for the feed shaft for the longitudinal and the cross feed. This one here is for the lead screw, and that's on a dog clutch, so that's a lead screw engage. On the carriage there's two levers. That one there engages and disengages your power feed, and that one engages the half nuts for the lead screw to do screw cutting. There's a little lever here in and out that controls longitudinal and cross feed. That's in neutral at the minute, so if I pull that lever, that lathe will start to, that carriage will start to move forward like that. Right, so we'll set the tool up, we'll touch the tool off, we'll do a scratch cut and then check it. Touch it off. Let's set a 0 on my DRO. We need 1.3 mil to get the full depth of thread. 0 the cross slide as well. And once I engage these half nuts that won't be disengaged, we'll just reverse the lathe. Right, so we need to take our first scratch cut. That doesn't look right. Right, it is right. It's exactly 12 TPI. I don't know why it looked not right. It just, well, it certainly is 12 TPI. Right, so the procedure is wind the tool out, reverse the lathe, tool back in to 0, plus a little bit cut, lathe it forward again, and on it goes until we get the thread down to full depth. You must adopt the same procedure every time. You've got to concentrate. It's so easy to fuck this up, it's untrue. Right, so taking the cut, stop the lathe using the chuck, R0, the cross slide, wind it out, reverse the lathe, back into 0, plus a little bit of a cut, lathe forward. I've got my DRO now, we're at 1 mil, depth of cut, everything's set up, ready to go. This tool is going straight in using the cross slide, not angled, using the compound slide. This is how these tools are designed to work. exactly the same. You must adopt the same procedure or you'll fuck it up. This tool is going straight in using the cross slide, not angled, using the compound slide. This is how these tools are designed to work. I'm going to do a spring cut on the same setting. That was no more feed on, that's just taking the spring out of the tool. Time to try things on now, I think. We're getting somewhere near. Settling back to 0 though before we start. Right, starting. I think what's happening is now the diameter of this is slightly too big. So I'm going to run a file across there and then take a little bit more. My DRO is now showing 1.3, so that should be the full depth of thread. Come on, you scum twat. It's good. Right, that's just what I wanted, absolutely spot on. Of course I can use this as a mandrel to machine the ring before we solder it together. So that's probably, I don't know, 2 hours work. I mean, I video at the same time just to make that. Like I say, I do enjoy doing jobs like this. I mean, I make one of them for the, whatever it's off, that'll be here long after I'm gone. You know what I do normally at work, motor cars, 10 years and they're gone. Once again, time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do. I am now perilously close to 100,000. I thought it was going to happen before the new year, but it's going to happen now, I think, in the next month. Anyway, thanks for watching.